Hello everyone, you're welcome to my YouTube channel. So today I will be discussing types of antimicrobials. Now, what are antimicrobials? Now, antimicrobial is a general term that refers to different types of drugs. And so these antimicrobial, they are used in the treatment of various infectious diseases. Now, infections and diseases may be caused by different microorganisms or pathogens, and in both humans and animals. And these pathogens can include bacteria, viruses, fungi, and parasites. Now, the drug that is used to either inhibit or stop the pathogenicity of these infectious agents is what is referred to as antimicrobial agents. Now, antimicrobials can either be of synthetic or natural origin. It is either they are being made from synthetic chemicals, or they are of natural origin. And so, the very first antimicrobial, which is antibiotics, that was discovered by Alexander Fleming in 1929. And that very first antibiotics was penicillin, and in, it is a broad spectrum antibiotics. And okay, so what are the types of antimicrobials? Now, the type of antimicrobials are usually antibacterial. They are categorized into four: antibacterial, antiparasitic, antifungal, and antivirals. Now, the very first one, which is antibacterial, these are a class of antimicrobials that is specifically designed or made to treat bacterial infections. That is, this class of antimicrobials, they help to inhibit or stop the pathogenicity of bacteria. And a very good example, as I mentioned before, is penicillin. And so, secondly, the second type of antimicrobial is antiparasitic. These are a class of antimicrobial that are specifically made to treat parasitic infections. They help to stop the pathogenicity of parasites. So, thirdly, we have antifungal. These are designed to stop fungal activities in both human and animals. And then we have lastly, antivirals. Now, antivirals are specifically designed to treat viral infections. So that will also take us down back to the first one, which is antibacterial. And a good example of that is antibiotics. They are further broken down into subcategories based on their action. So antibiotics can be broken down into broad spectrum, narrow spectrum, and also we have a single spectrum. Now, the broad spectrum class of antibiotics, they are specifically designed to treat both diseases caused by the gram positive and gram negative bacteria. That is why it is called broad spectrum. So they are able to target both gram positive and gram negative bacteria. And also, the narrow spectrum class of antibiotics, these ones, they are designed specifically to target a one particular type of bacteria. It could be only gram positive bacteria, or it could be only gram negative bacteria, but it doesn't attack both at the same time. And then lastly, we have the single spectrum antibiotics. Now, this class of antibiotics are responsible for targeting just a particular disease, a particular bacteria. For instance, maybe you have an infection that is being caused by Escherichia coli. Now, this particular antibiotics has been designed to treat infections caused by just that one pathogen. Then again, antibiotics is further broken down based on how they act, and this is include bactericidal antibiotics and bacteriostatic antibiotics. Now, the bacteriostatic antibiotics works in a way whereby it's able to inhibit the pathogenicity of the bacteria or the action or mechanism of the bacteria. But the bactericidal antibiotics, they function in the sense that they are able to kill or destroy the pathogenicity of the bacteria. So a very good example of a bactericidal antibiotics is penicillin, and a very good example of bacteriostatic antibiotics is erythromycin. So to go further with that, these antibiotics or antimicrobials, they have side effects. They have side effects because a lot of people tend to react to antibiotics, and some of these side effects could include vomiting, diarrhea, constipation, headache, and lots more. So now I want us to take note of this fact that antibiotics can also be used to treat parasitic fungal infections and including bacteria that they are actually designed for. But they can never be effective in treating viral infections. So viruses are a specific class of microorganism that you have to target with either their vaccine or a particular drug for it. And a good example of antivirals now is ribavirin. Ribavirin is a good example of antiviral, and that ribavirin is usually used for treating Lassa fever. So to go further, so different types of these antimicrobials has been abused by we humans, or is being abused by we humans, especially those into livestock farming and crop production. Now, excessive use in animal farming has led to the resistant genes of this bacteria to remain in those animals. And so when we humans consume those animals, and if the meat is not properly cooked, those resistant bacterial genes can be transferred simply by consuming those meats to humans. So this is why we need to join hands together to curb it. So again, other factors that has led to the spread of these antimicrobials is as a result of poor sanitation and then over prescription by clinicians. Most clinicians, they over prescribe antimicrobials a lot, and this is not good. And also lack of development of new antibiotics. Okay, now what are the impacts of this resistance that came as a result of misuse and overuse of these antimicrobials? And number one impact is that it has led to high rates of morbidity and mortality cases. And also it has brought about prolonged stay of patients in the hospital. You see a lot of patients in critical conditions whereby no antibiotics is working for their condition. And this is usually a very pathetic condition. And this is why we need to always take antibiotics when it is prescribed for us. And when prescribed, make sure you finish your dosage. Complete your dosage to keep antibiotics working. And not just for them to work, for them to remain effective when we need them the most. So antibiotics, they are wonderful pills, but they cannot cure all of your ills. For instance, you cannot have a viral infection and then you go and take an antibiotics. It's not going to work. And again, before you take an antibiotics, you should see your doctor. You should see your doctor, talk to your doctor, let him examine you, and then go for testing. Do the required test, and the reason why you are doing this test is to enable you to know what is wrong with you. That is, what infection that you have. Know the infection that you have, and then also know the type of antimicrobial that is suitable in treating your infection. So thank you so much for watching my video, and don't forget to hit a like on this video if you've learned something today, and also subscribe to my YouTube channel. See you some other time. Bye bye.